So today we're looking at task 3 for Algebra 2, and this is about inequalities. A lot of the rules from solving um, equations apply here with one big difference, that when you multiply or divide both sides of an inequality by a negative, you need to remember to reverse the sign, reverse the inequality symbol, flip the symbol. But otherwise, the rules from algebra apply. Generally, we talked about these last time. That means you combine like terms, get the x's all on one side, the variables, isolate the variables, and then just get one variable. That's a generalization, but those are good rules of thumb. Okay. Um, and just as with equations, some equalities have no solutions, but now that we're in Algebra 2, we're calling that solution set the null set. And some do still have all real numbers as solutions. That happens when you get an identity that's always true. Okay, so let's go ahead. These are long notes, so I want to go fast so we get this in one video, I'm hoping. All right, so now we're going to solve this. I think the first thing I'd like to do here, rather than mess with this fraction, is multiply both sides by 3. That's just a little quick trick you can do if you don't want to deal with fractions, so that you're dealing with all integers as coefficients and constants. So let's multiply this entire thing by 3. Isn't that handy? Okay, so then we have negative 2d minus 3 is greater than 21 plus 6d. Now, I happen to like my variables on the left. Sometimes I suggest that you add, if you've got a smaller negative over here, that you add that to both sides, and then you'd end up with your variable on the right. But just for kicks, and so that we can demonstrate this flipping the sign when divided by a negative, let's go ahead and subtract 6d from both sides. So we would get negative 8d minus 3 is greater than 21. And then we want to isolate that variable term. So then we have negative 8d is greater than, we're going to add 3 to both sides and get 24. Now we need to divide both sides by negative 8. And to do that, when we do that, we also need to remember to reverse our inequality sign. So d is less than negative 3. All right, so then when you go to graph that, it's an open circle, and the arrow goes to the left. Okay, so go ahead and hit pause so you can do the U-try. All right, with the U-try, I want to go ahead and use the distributive property. So 6x minus 12 is less than or equal to 3x plus 4 minus x. I'm going to combine like terms on the right. 6x minus 12 is less than or equal to 2x plus 4. Now I'd like to have all my x's on one side, so I'm going to subtract 2x from both sides and get 4x minus 12 is less than or equal to 4. I want to isolate my x term. I'm going to add 12 to both sides. 4x is less than or equal to 16, and I want just 1x, so I'm going to divide by that 4. We don't need to reverse the sign because 4 is positive. So x is less than or equal to 4. That means we have a solid dot, and again the arrow goes to the left. I didn't draw a very straight arrow. Oh, I do have a ruler here, so next time maybe I'll actually draw a straight line. Okay, now let's look at these, and bear in mind our little caveat up there that we might end up with a null set or all real numbers. Let's take a look. Okay. So I'm going to combine like terms. 5x minus 2 is greater than 5x minus 7. I'm going to subtract 5x from both sides. We can do that as long as we're subtracting the same thing from both sides. So then I get negative 2 is greater than negative 7. Is this true? Yes, it is. Negative 2 is to the right of negative 7 on the number line. So this is always true. So the solution set is all real numbers, or you can write real or X is in real, well, you know what? X is the set of all real numbers, or you can write all real numbers if you prefer. Okay, but how would you graph that? You do have to graph it, and the graph just looks like a line that covers the whole graph in both directions. Okay, now you try, so go ahead and pause and come back when you're ready. So I'm going to combine like terms on the left and do the distributive property on the right, both in the same step to save space. So I have 10x plus 9 on the left after I combined like terms. I have 10x minus 5 after I did the distributive property on the right. Again, I can subtract 10x from both sides, which gives me 9 is less than or equal to negative 5. This is not true, so my solution set is the null set. And that means I don't graph anything, I leave it blank. All right, now let's look, let me just say this. If you want to see if you graphed it correctly, pick a point. And this is going to come in handy later on when you're graphing much more complicated things. So it doesn't really help with either of these graphs, but let's pick a point here, okay? Let's pick a point to see if we graphed in the right direction. Okay, let's pick negative 5. It's in our graph, so let's see if it's true. Negative 5 is less than negative 3. See how that works? It's a very nice way to check that you graphed in the right direction. Okay, keywords in word problems. More than, well, that's just our greater than sign. No less than. That can be confusing because of that word less, but it's no less than. So if something's no less than 5, that means it's greater than or equal to 5. Greater than or equal to 5. Less than, okay, at least. Well, that's another greater than or equal to, isn't it? At least, if I have at least 10 cookies, I have greater than or equal to 10 cookies. What if I have at most 10 cookies? Then I have less than or equal to 10 cookies. What if I have no more than 6 mosquito bites? Then I have less than or equal to 6 mosquito, I almost put the 6 mosquito bites. Now, if x is between a and b, and I did not add that I'm assuming a is less than b in this circumstance, then you can write that a is less than x is less than b. See how x is right in between? Now, if you say x is between a and b inclusive, then you use the less than or equal sign. Less than or equal to x is less than or equal to b. All right. So let's look at a couple of examples. We're not being asked to solve, we're just being asked to write an inequality that represents the situation. You can work at most 24 hours per week on your job. So we've got 24, and at most, well, let's look up here. Oh, that means we're going to work less than or equal to 24 hours per week. So far this week, you've worked 7 hours. The remaining shifts for the week are 4 hours long. Let S represent the number of shifts you can work this week. So S is the number of shift, and you're getting 4 hours per shift. So 4 hours times S is the total number of hours that you're getting if you work S shifts, plus that 7 hours. All can't be more than 24. You can work at most 24 hours per week on your job. Okay, now here's another one. You're saving money for a summer camp and need at least $600. So here's my 600, and you need at least $600. Well, at least is greater than or equal to. You have saved $200 so far, and you have 8 more weeks to save the total amount. M is the amount you need to save each week. So you need to save 8 times M plus that 200 that